Hey, I'm Lucas, and today I want to show you how you can add error tracking to your application. So why do you want error tracking for your apps? So error tracking is something that is very, very helpful in a production setting. If you have deployed your application, if you have a couple of people using them, and out of a sudden they're running into errors and they're reporting, this doesn't work. But of course you have no idea what is going on their machine, and you can't possibly take your car and drive to every one of them and open the dev tools and check the console. So this doesn't work. So what you usually do is, as soon as an error happens, you will send the error message to a centralized place where you collect all of your errors. Without further ado, without me telling you how it should look like, let's get into it and you can see how it works. I will go to my code editor, and first thing that I'm going to do is create an example application. For the example application, I will use, let's quickly go back here. I will use the Nux framework. I really like using Nux and I had some good experience with them. So let's go to the homepage, grab this little code snippet, which will guide us through the setup process. I will paste it in my terminal and hit enter. And I will write a dot in order to install Nux in the current directory. Yes, I do want to override everything that is inside right here. And I will just use npm as the package manager. So let's hit enter, and Nux is installing all of the dependencies that are necessary to run the application. Of course, you don't need Nux in order to set up bug tracking, and you can basically use the framework of your choice or even set up bug tracking server side. Everything has been installed. Let's hit yes. I want to initialize a repository and I don't need any of these additional modules for our little demo right here. If we write npm run dev, we can spin up a development server. It is listening on localhost 3000. So let's quickly go over to localhost 3000. Our application is running and things are looking good. Let's go back to Bugsink, click on the Docs tab, and if we scroll down a little bit here on the left side, you can see the installation instructions. If we go to the installation overview, so full installation guide, if we scroll down a little bit further, these guides cover the most popular ways you can deploy the Bugsink server, and as you can see right up top here, there is the Docker installation, and that is what we are going to do. We will install Bugsink with Docker. Now you can install Bugsink on your own machine, but of course if you close your laptop, you won't be able to collect any bugs anymore, and you probably won't want to give everyone access to your local computer on the internet. So let's install Bugsink in the cloud. I will go over to Sliplane.io, and Sliplane is a cloud provider that makes it very easy to run Dockerized application. And a lot of times what you will find with open source software like Bugsink, they can be installed using Docker. So Sliplane is really the perfect tool to run our application. So I will click on get started with GitHub. Then I click on create project, and I will call this project Bugsink. Project has been created. I will click on the project and I will click on deploy service. First step, we will have to create a server. So I will click on create server. Then I can choose a location for my server. I will run with the default. You want to choose the location that is closest to yourself or to your users. Server type, I will choose the default server. It's priced at €9 per month, but it will only be billed for the time that the server is running. So if you decide after 3 days you won't use it anymore, you will only get charged for the 3 days, or 1/10 of the price basically, which is 90 cents. Prices are in euro, but it's around, let's quickly see, €9 in USD, which is around the same basically. The course is at 116. Okay, so let's name our server. I will call this one Bugsink as well, create paid server. And then after a few seconds, the server is created. I will click on the server, and then I will quickly go back to the installation overview, click on Docker installation. If we scroll down a little bit further, you can see in order to install Bugsink with persistent data, we can either choose MySQL or Postgres. Now, normally I would choose Postgres, but in this case, it says the setup has not been extensively tested with Postgres over here. So let's just use MySQL in this case. In Sliplane, if we scroll down a little bit further, we have some pre-configured images, and we can use the MySQL image in order to deploy a database on our server. Now, I do not want this database to be publicly available, so I will disable this little toggle right here. And it just means only other services that are running on the same server have access to the database, so no public connections are possible. If we scroll down a little bit further, the preset already put in all of these environment variables for us. And the only thing that I want to change right here is I want to rename the MySQL database instead of default. I will click on the little pen to edit it. I will also name this one Bugsink. And if we scroll down a little bit further, the last setting that I want to change is I want to give this one a different name. Instead of MySQL WXMH, I will call it Bugsink MySQL. Click on deploy. And after a few seconds, the deploy will be in progress, and I can click on the service and see what is going on right here. So service is deploying. It should only take a few seconds as well to deploy this application. So we have our database running, and we can use it to connect with our Bugsink instance. So next step, we will deploy the Bugsink application. I will click on deploy new service, choose the Bugsink server, and then I click on registry. Right here in the image URL, I will type Bugsink. And now it's going to look for the Bugsink image on Docker Hub. And as you can see, we found something. I will click on it. And next step, we will need to choose the version which will be deployed. I will choose 1.6.2. You could also choose latest, for example. But in a production-like setting, it's always recommended to use a pinned version so you don't accidentally upgrade your application. And maybe there was a bug introduced which breaks my setup. So in production, always use a pinned version. If we scroll down a little bit further, this time I do want to expose my service. And if we scroll down even further, there are the environment variables. And if we go back to the Bugsink Docker install instructions, you can see there are a few environment variables that we need to configure. So two are required in order to run the application, which is a secret key right here. I will copy secret key from the documentation, and I will just grab this key that is displayed over there. As you can see, if we refresh the page, there is a new key, and the key is always generated. But of course, you don't want to rely on this if you don't know what's going on underneath the hood. I don't know what's going on underneath the hood, but this is just a demo, so for me it's not that important. But if you want to be super safe, you would plug in your own secret key right here. So let's also grab the second environment variable, database URL, put it in right there. And as you can see, this environment variable contains placeholders. We have this user, password, host, and name. And if we open Sliplane in a new tab and navigate to the database that we just created, we need to grab the environment variables that have been specified over here in order to fill in these placeholders. So user is going to be root, and then we will grab the root password from the environment variables of the database. I will paste in the root password, and the host name, if we need to scroll back up again, we can see this internal host, which can be used to connect to our database. I will replace this internal host and get rid of the port, and the name is the name of our database, and we named our database Bugsink. So let's click apply. You can also see the name of the database right here. My SQL database is called Bugsink. Okay, so Bugsink, it is possible to run Bugsink with only these two environment variables, but it won't work in our case because we need to apply some more settings in order to use it. First of all, creating a super user. First time that we set up Bugsink, we can create a super user. There is this create super user environment variable that we can add right here. And the format is the name of our user. Let's use admin. And then there is a password that you can choose. I will use password for this demo right here. And another setting that we will need is this reverse proxy right here. Because if we deploy something with Sliplane, by default, it's going to be HTTPS. So it will be encrypted. The traffic will be encrypted. So we will also need this behind HTTPS proxy setting over here. And as a last step, I will rename this to Bugsink and click on deploy. And it's already, the deploy is already live. So I will click on this public domain, and as you can see, yay, our application is running. So last thing that we need to test, can we log in? I will type in admin as the username and password as the password, click on login, and it seems to work. So I'm inside Bugsink right here, and you can see the user interface. I can click on create a new team and give this one a name. I will call it Sliplane for the demo. Click on save, and I can also create a new project and call this project, for example, bug tracking demo. Click on save, and after we created a new project, I can see a little instruction how we can connect our application to this Bugsink instance. If we have a closer look at this connection string, I can see localhost as the host name, and this is not correct because we are missing another environment variable, and it is called base URL. I will copy this public domain over here, click on copy, and I will add a new environment variable and call this one base URL. And then I paste, I think this time I need to add the protocol as well, https bugsink.sliplane.app. Click on save. New deploy is in progress. The deploy has finished. I will go back to the application. I will refresh the page, and now you can see the host name has been replaced. Instead of localhost, we're now using bugsink.sliplane.app. Okay, cool. So our Bugsink instance is ready to collect data, but Bugsink only provides the backend where we can send our error messages to. And in order to send our error messages, we will use one of the Sentry SDKs. There is a link hidden in here. It doesn't look like a link, but you can click on this Sentry SDKs. And if we click on it, we will be redirected to the Sentry documentation. So Sentry is a bug tracking tool as well. And they even provide a self-hosted version. You can see right here on the left side, there is this self-hosted version. But if we take a closer look at it, the minimum system requirements are 4 CPUs, 16 gigabytes of RAM, and 20 gigabytes of free disk space. So it's a very, very large application, and it's pretty heavy. I guess for 99% of you it is overkill. So we can also go with the much lighter version of Bugsink. Let's go back to the Sentry documentation, the client-side Sentry documentation platforms. If we scroll down a little bit further, there's search SDKs, and I can type in Nuxt and click on Nuxt right here in order to see the installation instructions for Sentry. I tried this Sentry wizard before, but I had issues connecting to Bugsink using the wizard. So I will click on manual setup right here. in order to do all the steps that the wizard would do, but do it manually. So first thing that we have to do is install Sentry in our application. So I will jump back to the next project. I will open a new terminal, paste in the npm install command, and hit enter in order to install the Sentry SDK in our project. After a few seconds, the Sentry SDK has been installed, so we will continue with the installation instructions. Next step, we will add Sentry to our as a Nuxt module. So in the nuxt.config.ts, I will add this little line in order to tell Nuxt to use the Sentry module that we just installed. Then we need two configuration files, a sentry.client.ts and a sentry.server.ts. So I will create these files right here. Sentry.client.config.ts. I will paste in the client config code, and there is this bracket which is wrong. I think they have an issue in their documentation right here. And I also need to pass I also create the sentry.server.config.ts, and the code is basically the same right here. Now in both config files we need to swap out the DSN for the DSN that we are provided on Bugsink. So right here, this DSN will be swapped out. And don't forget to save these two configuration files. And on the server side, I will get rid of this send default PII. Okay, so Sentry recommends, and it's usually something that you would want to do, to move these DSN strings to environment variables. So we can create a new file, name it .env, add this Sentry underscore DSN public, and paste our string right here to the environment variables, and then use the environment variables using this little section in our Nuxt config. So we will import all public environment variables right here that can be used client side. So in Sentry you can then use this one right here. Okay, so server side, it works a little bit different. We don't have access to this public environment variable right here, and we need to use process.env.sentry.dsn public. And we also need to make sure that this variable is present in our environment when we are starting the server. So there is this package, you might have heard of it, called .env, and we can install .env in our project as well. And if we scroll down, npm install, blah, 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 there is this import .env/config that will load all of the environment variables that we just stored in this file right here and make them available as process.env environment variables in our application. So Sentry is set up and we are ready to send data to Bugsink. So let's quickly test if everything is working. I will go back to the app. I will add a script setup down here, make the language TypeScript. And then I will add an onMounted hook. This is all Nuxt specific code, but it doesn't really matter. And in here I will throw a new error. This is a test error for the Nuxt error boundary. No, not really, but this is a test error for Bugsink. I will save that. And then in my application, I will open the console. If we refresh, oh, this is a test error for Bugsink. We're not catching this error anywhere. And the application crashes. But if we go back to our Bugsink instance, I will click on the project that we just set up, as you can see, we do have a new error in the project. This is a test error for Bugsink, and with 3 events, the error happened 3 times. If we go back to the application, I will refresh it a couple of times. Application crashes. If I refresh over here, now it happened 7 times already. And we can see we are collecting the error in the application. If we have a different error message and refresh that right here, oh, we have another error, and it only happened once yet. So the connection is working. Sentry is sending data to our Bugsink instance, and Bugsink is listing all of our errors in our project exactly as we wanted it. So let's click on one of the errors and see what is going on here. I will click on it, and you can find all kinds of different information that might help you debug the issue even further. You can see in the event details there is a title, event ID, Bugsink ID, and so on and so forth, timestamp and whatever. You have all kinds of different information. You can have breadcrumbs. There's the event list when it happened, so you can see all of the different timestamps that the error event occurs, the environment and release. And you can see environment is set to production, and release we don't have any information about in what release this occurred. And these are some information that we should add to our Sentry config. So in the sentry.client.config, we can add, I think it's called release, a release. And if we tag this one with a version 1.0.0, and then we will trigger the error again. I will refresh the page. And then right here in Bugsink, in the project, go to the event list. Oh no, it was the other one, I think. Bugsink project, this one right here, go to the event list. And now you can see this error happened in this release. Because one thing that we can do, if we fix the error, say, oh no, why are we throwing a new error on mounted? I will fix it. I will create a new release. And then I say, okay, this error right here has been resolved in the next release. So I will click resolved in the next release. So I'm not getting spammed with these millions of error messages that are happening over the past 10 releases. So if the error is happening again in that old release that was 1.0.0, and we will throw the error again, refresh this a couple of times. In Bugsink, there is no new error showing up right here. So this is the old error. As you can see, we appended this too. This error that we just triggered, it's not showing up because we told Bugsink it is already resolved in the next release. However, if we are upgrading our release version and the error still happens, so we have a new version that Bugsink doesn't know about, then you can see the error is showing up again. So if we take another look at our error and we will inspect the stack trace, we can see error. This is a test error, and it is telling me that it's happening somewhere right here in this _nux/app.view file in line 14. And if we go back to our code, app view file, then we don't even have 14 lines right here. So it is pointing me towards somewhere else. And the reason for that is when we spin up the development server, Node can't actually run app.view files. They can run JavaScript files. So our build tools that are running, that Nux is using under the hood, they will transform this view file into a JavaScript and HTML and possibly even a CSS file that will be executed by Node. The stack trace is basically pointing to these compiled files or transpiled files that Nuxt is generating automatically, and this is basically useless for us because we can't pinpoint where our error is coming from. And to solve this issue, there is something called a source map. And if we jump back into the Sentry documentation, we can see how we can get readable stack traces with source map. It is optional, but it is highly recommended to use source maps. As you can see, we need to add this little configuration to our Nuxt config. I will go back to Nuxt config, create a new section Sentry, and then we have this source maps upload options, the organization. Let's go back to our Bugsink instance. We named the team Sliplane, so I will write Sliplane, and the project was named bug tracking-demo. So I will put in bug tracking-demo with one T, of course. Then we need an auth token in Bugsink. We have this token section. I'll click on add token, can generate a new token, paste in this auth token right here. And of course, you can also, or you should actually store this one and call this one Bugsink token. You should store it as an environment variable and replace this right here with process.env.bugsink token. You can also store these settings as an environment variable, but the token is a secret and it shouldn't be included in your version control. And another setting that we need to add is the URL, which is bugsink.sliplane.app. I will save this, I think, without the / at the end. And another setting that we need to apply, if we go back to the Sentry documentation, Nuxt generates source maps in server-side by default. You need to explicitly enable client-side source maps in your Nuxt configuration. So let's quickly grab this source map snippet right here, paste it in, hit save. So source maps, they are only uploaded during the build process. So we actually need to run npm run build. And then it's building Nuxt for production. And if we have a close look at the logs right here, you can see we are getting these logs and source map upload report. And then it says successfully uploaded source map to Sentry. And every time we run the build, Sentry is uploading these source maps to our Nuxt instance. And if we run node.out-server-index.mjs, so we are running Nuxt in production mode and not development mode. If we open the URL, we will get this 500 error. This is a test error for Bugsink 2. And we will check again in our Bugsink instance. I will just refresh the page, and Bugsink now has access to these source maps. And as you can see, the view changed a little bit, and in our stack trace, we now get the error is in our app.view file in line 10, and it points exactly to where the error is happening. And if we compare it, oh, it is in line 10. Oh no, why are we throwing this error right here? So let's uncomment it and release a new version. Now you can of course automate this release workflow somehow, and with every push to a GitHub repository, bump the release or whatever you want to do. But this is basically how it works. And the last thing that I do want to mention right here is notifications. So in our Bugsink project, if we click on this megaphone, we can see that we can enable notifications either via email You can enable notifications via email by going to the Bugsink documentation, click on the docs, and in the settings right here, we can add a bunch of environment variables in order to enable email notifications, which is something that I highly recommend, because every time a new bug comes up, we are getting notified instantly about this bug. And if we resolve the bug, or we can also mute a bug if we want to disable notifications for this bug, we won't get any notifications. And you can also add, apart from email notifications, you can also add Slack notifications, for example. If you prefer getting notified in a Slack channel or via Slack message, you can paste in the webhook URL from Slack right here and get notified about your bugs. So this is basically all you need to know in order to get started with error tracking and add error tracking to your application. Of course, you don't need to add it to a Nux project. You can choose the framework of choice or add it to your server as well. And of course, there are a bunch more settings that you can tweak in Sentry and in Bugsink that you can read in their documentation. I hope you liked this video. If you did like it, give it a thumbs up, comment, and subscribe, and I see you next time.